So the first thing I do here is I'm like, well, I've got a mutable list. So what I'm going to do is create, I want a wrapper to create an immutable list. This is a kind of helper function. And what it does is it takes my mutable list and it wraps it in this very list itself. So it's a recursive call. This will allow me to generate new lists, should I need them. And especially what it will allow me to do is when I return something from my functions, I'm not going to return that stateful list, the array that was passed in. I'm going to give you a brand new immutable list, okay, which you cannot mutate. That's the goal there. All right, let's do this. I think what I'm going to do is I'm just going to look at this one line at a time. And can we see? Can you see this? This is the array syntax value of index, and I just gave it a name, which is value of index. Give me the member at this index, the value at this index, whatever it is. How do I do that? I open up the mutable list at that index, and I return that value. Now, I don't have to worry about mutation here. Why?
Because you're returning a copy.
Well, yes and no. Even if I wasn't returning a copy, because I've done a slice as my initial value, which is a copy. Even so, this is actually one of the non-mutative functions of an array. So when you look up the value at a particular index in JavaScript, this does not mutate anything. This is one of the challenges of JavaScript. You never know when something's going to mutate something and when it's not. So in this case, no mutation. I don't have to worry about that. Does that look pretty clear? There are no questions. I think that we're all on the same page. Let's go to the next one. All right. Now I added my append function. Now this is, if you're in the closure class, this is the association or assoc. Alternatively in JavaScript, this is your push. And what I'm doing here is I'm first taking my mutable list, and I'm actually going to use that function. I'm going to push something onto it. I'm going to push the new element. But then you'll notice what I'm doing here. I'm not going to return that list. What am I going to do? I'm going to return the immutable list, which is a version of the existing mutable list. And it will copy that data, because that's the first thing we do, is it copies the data when you create that list. And it will be the new data that has been mutated. This is probably confusing, but raise your hands if you need help on this. And you can go talk to those people. Okay. No. All right. So this would be a problem. If I allow you to do an append, and I pass out as a result of this the mutated list, then it prevents you from operating on that list in the same way that you could operate on the original list. What I've done is I said, you can operate on my list, but from the operation, I'm going to give you a mutable array. So you can take my immutable list and do something to it, but you don't know what you're going to get back from it. In this case, I may give you back the original array, in which case you're back in the world of mutation. Or, and this is very important when you're going to design classes like this, you want to always ensure you're going to pass back something that's immutable. Remember, one of our guiding principles is not to make mutable things. So I'm not going to give them a mutable array back. I'm going to give them a list. Does that make sense? An immutable list. Does that clarify that a little bit? All we're doing here is returning the mutated data inside this immutable wrapper of ours. Are we still confused? Good. Let's move on then. So now we've done the push function. Now let's do the unshift function. So in this case, I've chosen, as I chose append for my first method, I've chosen prepend for the unshift, and you'll notice I'm doing exactly the same thing. I utilize the native mutative function on my copied array. I then pass that copied array into a new list, and I return that to the user. So again, they're not going to have to deal with an immutable array. They're going to still be dealing with my immutable list. Are there questions about that one? Yes?
This mutates your object. Your mutable list function, your instance mutable list function
Yes.
is modified.
Absolutely it does. And you're like, but you're mutating something that's wrong. You're
yes,
right.
You can't, if you do this on the same list over and over again, you're going to get different
You can't do it on the same list. Notice what I return.
But you can say the reference to that list, call prepend, and then call prepend again on it again. So this is still mutating an object you could keep around.
That's actually true. That's actually true. So one of the costs of this kind of operation, this is a simplistic way to provide a wrapper class. It has costs. And one of the costs is that actually you are mutating stuff under the hood. And as he pointed out, in this case, what you could do is you could kind of treat it like an array where you save this value and you keep pushing stuff onto it. Now that should be prevented by the paradigm of the use of this class, but you could do that. And in fact, every time you push on change, we're using those native mutated methods, we're actually mutating an instance variable on the class, which is not a good thing. So this is like the intro. How can we just create, according to the specs that we gave, we're creating a class that does not expose any mutative methods, that does not mutate the data when you enter it, and that exposes methods for operations that are non-mutative. So we're just trying to fit those particular criteria, but what you want to do at the end of the day is probably come back and refactor this and extract the use of the native array functions, which we'll learn to do, and you'll know how to do by the end of the session. But you'd want to refactor that to modify this so that you're not using any array, native or mutative array functions, because they are bad, they are evil. Mutation is evil. It's a good call.
Because couldn't you just put the value into a one-item array and then concat the mutable list and return that?
Yes.
And then
You can
your
use
values-
concat to do
and there's no
exactly the same
mutation
thing.
whatsoever, still return your immutable list. So you kind of get, then you have it all, right?
Yep, you're exactly right. Concat is actually a very clever way to cheat and get this, because what concat does is it takes two separate arrays and it gives you a brand new one. It's again a useful function in JavaScript to avoid mutation. So you could definitely, what you could do here is, and you have your,
I think likewise with shift, you could have done slice, right?
pardon?
You could have used slice instead of shifting for the other one.
So slice is not a problem in and of itself, but you're correct. For either the append or the prepend, both of those can be accomplished with concats evenly. You just change the placement of them. So
Right.
in this case, let's do var original is equal to 1, 2, need a comma, and then var new is equal to 3, 4. Right. Array. And now we can do original dot concat, and we can pass in new array. Like so. And this gives us 1, 2, 3, 4. So that's the way you can append a single element. Or what you can do is reverse these. 3, 4, 1, 2. So it's a way to insert items either at the beginning of a set or the end of a set without creating any mutation. But really, and we'll talk about this later on, the way you want to do this is probably recursive. The best way to do this is probably a purely functional recursive call. So, but we'll get there. So yes, this causes some mutation. It is kind of bad, but it's better than what we got to start with. And hopefully it looks familiar. Let's look at the last. Oh. Wrong key. There we go. Concat. And this, unsurprisingly, as we just learned, concat does not mutate anything. So what you can do is just return a new list in which you're concating your current list to the list that is passed in. Because again, it's not mutating anything. We don't have to do anything special. We don't have to do any kind of cloning. We don't have to use anything else. Concat is a very helpful function if you're to do this. What does this look like in finalized form? And again, if you've downloaded the slides, this is at your fingertips. Come on. There we go. You'll see that cat later. This thing. This is basically a cheap, semi-immutable data structure. And if we get there, we're going to come back and we're going to modify this after the fact and make this more useful. But what this does allow us to do now that is rather nice is this. New list, we pass in an entry of 1. We're going to append a 2 to it. We're going to prepend a 0 to it, and we're going to concat it with a 3, 4. You notice we're chaining those calls, and we get 0, 1, 2, 3, 4. Yes.
You know that for you, like in append, prepend, you actually modify the mutable, that is that mutable, but in concat you didn't.
So Can you restate the question for me?
Yeah, so in append
Mm-hmm.
and prepend, you modify the mutable first, then you return a new list. Therefore, whenever you recall it, like your previous like mutable list is something different, whereas like when you did concat, you didn't modify the mutable list. That you
Correct.
had.
So prepend and append both use the native JavaScript arrays push and unshift to accomplish the same thing. We could change that to use several different methods to prevent any kind of mutation at all. Now what those are doing is those are mutating the state of the set instance variable that is the value of the original set. So yes, we're mutating in both of those. Now, would you really want to avoid that? Yes. For the sake of this talk, I want to go with the simplest, most commonly known thing, which people know push and they know unshift.
But what I mean is that like if you do that concat before and then you do that append something, like that might not work. I think.
So you're saying if we swap this and you do a concat and then you do an append and prepend?
Yeah, that's it.
So this would, let me actually do this. Let's do this.
Or because you didn't modify the mutable inside. Just the detail.
Okay, so we're going to create a list, we're going to concat it, and we're going to pass in, let's just do that. Going to concat the list, and we're going to prepend to 0. Does that work?
Let's see. I don't think it would with
No. And then we can call that.
So I think what we're both saying is if you save the output of the expression,
Yes.
new list concat, and then as a variable a, and then you did a dot append 0,
Yes.
a dot append 0, you're going to get two different results.
Correct. Yeah, I think that is what I've acknowledged about both functions is that for both append and prepend is written on the screen, and then we have other versions that hopefully we'll get to later. For both of those versions, they do actually cause internal mutations, such that if you save the variable of a list and you keep calling append on it, then you reference the original list instead of the values of the functions, which are in fact pure. But if you reference the original variable, you'll notice that its state has changed, and it's because it uses JavaScript mutation or array mutation under the hood. Does that make sense to everybody? Are we clear on that? Okay, good. Are there any questions about that? Good. So that can be written a lot of different ways, and you can solve that problem later. In fact, we hopefully will solve that problem later. But if you are depending simply upon the output of the values, then, which in this case we are, for instance, this function, the one that I referenced in the presentation here, what you're able to do is, because from each one of those operations we're returning a list, you can continue to chain calls. So in this case, we can operate upon that list indefinitely with these operators, knowing that from each one of these we return a list that we can continue to operate on uniformly. So this is a similar syntax to what other library that's very common in JavaScript? Anyone know? Hazard guess? Nope, Jquery. So the fact that you can chain methods over a consistent object and it performs operations on that object repeatedly, this is actually something that Jquery has borrowed from the world of functional programming, where we have operations that return a value that operates consistently. So we can keep operating on those sets or on that value of sets over and over. You cannot do this in JavaScript because you have operations like push that return. I think push actually does return the merged, or I think it returns the full array, but I could be wrong. Unshift does not. No, push returns I think the index, the position, right? And then unshift does the same thing, whereas other things like concat will return you the whole array. In this case, we always return our immutable list, and that's why it's important in our return functions to not return something other than our list unless it's going to be a value itself, like length. All right, how many of us are lost at this point? All right, so let me help to get you unlost because I think it's important to get you there before we move on. What is the challenge?
All of it. Like, I understand
All of it? Is there one thing I can clarify?
So why can't we do this in JavaScript again?
You can do this in JavaScript, but let me show you what it looks like. Look at the number of operations I'm doing here. So I've got a list.
Yeah, 3, 4.
What does that look like without the immutable list? That's what it looks like. That sucks, frankly. Look at all the things you've got to do. Or you could do that. Which is easier to reason about? Take a list that has one member, append something to it, prepend something to it, and then concat it or join it with something else. Does that make sense to your minds? Like, is that hard to wrap your brain around? How about that?
So this is an argument for monads.
This is an argument for monads. But you need immutability. You need functional constructs for monads. You're absolutely right. This is very hard to reason about. This is error prone. This is something that if I write, and 2 weeks later I look at it, I'm going to be like, who wrote this? And I've got to try to figure it out again. This anyone can reason about. Get a list, stick something on the front, stick something on the back, and then join it with something else. Piece of cake, right? This is why immutability and monads are very, very valuable. So now, let's go on to another problem. We've created an immutable list. Did any of you actually get a full list there that could operate? Good. Talk to that guy. So again, you can download that. And what I'd suggest doing is if you have that, make sure you copy it so we can use it, because we want to add to that code later on. Ideally amend some of that code later on. But before we do that, I also want to work you guys through an immutable map. We've done it with one of the fundamental data types in JavaScript. That's the array. What's the other fundamental data type? It's the object, the JavaScript object. So we can do exactly the same thing that we just did with a list with an object. We're going to change the name up a little bit, though. We're going to call it a map. We want to create a replacement for the JavaScript object class that does not mutate the initializing value of present, does not expose mutative methods, and does mimic the following methods. That is a key set and a key get, which you can do several ways in JavaScript. So we're going to set the value of a key on a map, and we're going to get it. Only two methods. Should be a little bit easier. Oop, I don't want to show you that yet. So do we know how to get started from here? Are we pretty comfortable with that, or would you like me to walk through that kind of the way I did the last one? Do you want a chance to work through this yourself? Raise your hands if you do not want a chance. All right, for those of you who raised your hands, I will come up and help you. For the rest of you, please code away. Write me an immutable map that allows for a set and a get. And then we'll review that when I get back. So I forgot to clarify something in terms of setup. What you want to do, if you want to work with JavaScript, is open up the Chrome console. Chrome is best because when you use recursion, you can start crashing the browser from using Chrome. So open up the Chrome tab, and go to the whole console, and you can write in there. That's kind of what I was doing. I would suggest that if you do that. But there are lots of ways. That's why you need like test.
As far as key value
So one other thing I'm going to do here, I didn't realize in advance that the presentation I placed online would make it difficult for you to copy this code. So what I'm going to do is find our chat room and I will paste examples in there. It's room A115. And this will make it easier for those of you who would like the code. I think I might have lost my connection here. It should make it easier for you to follow along. That would be wrong. Blah, blah, blah. There we go.
How do we come to see the other channels?
You can go up here to channels, and then you can browse by them. I just searched by 115.
What was it, 115?
115, A115. Which I cannot seem to join. So that is the basic list function. Again, this is not a completely pure class. It gets you halfway there, and you can modify this fairly straightforwardly if you want to use concat to solve the same problem. At the end of the lecture, we're going to try to solve it with recursion, which will be fun, probably. All right, so how many people are still in desperate straits on this? How many people have successfully solved the map problem? I don't want to see your hands up anymore. What is the hardest part of this problem? So there's only two methods. What's the hardest part?
Having making a clone of the object.
Exactly.
We're using object assign. Which
Exactly.
You can't always assume you have, right?
That is absolutely correct. So let's take a look at this guy. Huh. All right. There we go. Sorry. At the map. And what you'll notice here is that my functions are actually really simple. Can you see this? Oh, no, you can't, of course not, because it's not large. There we go. Is this well enough and visible here? So what you'll notice is that most of this, about half of this class, is taken up by the shallow copy function. And it's named very specifically for that reason. We'll talk about that later. Before, let's talk about the other functions, though. Once again, I create a toObject function that lets me actually kind of like print that out and give me the original object instead of my class. I have a set method that takes a key and a value, and you'll notice here that I'm actually, again, using mutative methods on an object. And I'm returning a new map that wraps those mutated values. You notice that my get's the same way. I'm going to actually reference that mutated or that mutated structure, the original one that we passed in, I'm going to give you the key to it. That is not a function that actually mutates anything, even though it is on the original object, because a get doesn't change anything, only the set. Now the real key to all of this is the top function, which is the shallow copy, because when I do my mutation in my set function, I'm not doing it on the original object, I'm doing it on a clone of that object. And this is a very problematic thing to do. It's problematic in the original function, though that was not as obvious during the presentation, because we were doing a slice there. That copy is simplified in JavaScript there, but it is no less problematic for reasons we will talk about shortly. So let's do this. The way that I chose to do a shallow copy, and I say shallow because we're only doing one level deep, objects can be infinitely nested, so there could be n number of key value pairs and n number of nestings within those key value pairs. So it's this unlimited problem if you're trying to do a clone. Let's say you have this. We've got an object. That's easy. This is a little bit harder. This is even harder. These kinds of problems are very, very hard to solve when doing cloning. And they're even harder because when we copy these data structures, we're using mutative structures to start with. These are all things that can be mutated. Well, not the strings, but the array here and the JavaScript objects can all be mutated. So whenever we do a clone, you're faced with the possibility that you will have impure data inside of your source. So, but this is basically what you got. You have some sort of copying mechanism. There are a bunch of different ways to do JavaScript object copies. This is a very naive one. This is basically what you got, yes? Copy over all the values, and then we wrap the mutations on that copied object when we pass in our second map. Are there any, is this unclear to anyone, what we've just done here? Good. That allows us to do, again, the same kinds of operations we performed before. We can create a map. We can set a name. We can set an age. We can set a has ring value. We can create it to a to object, and what do we have? Pure value from pure functions. A pure value from pure functions. Now this class suffers from the same problem as the last one. It's actually not a pure class, but the methods give us exactly what we want. All right, we're going to pause here. We're at about the 1 hour mark, so we're going to take a 5 to 10 minute break. Feel free to head out. I'm going to be available up here for any questions. We can work through some live coding examples before we move on from this, but please take a little bit of time, go get some water, stand up, move around, and we'll continue in just a minute. Thank you very much.